Okay, hi everyone. We're still working with a slope-intercept form. Let's try slope-intercept form again, and let's do a quick review what this is. Okay, algebra isn't just about solving for something, but it's also looking at characteristics and seeing there's relationships and there's patterns. And you've been doing that in math all the time. When you first learn your multiplication tables, 3 times 1, 3 times 2, 3 times 3, you learn there's a pattern to it. And if you just straight memorized it, maybe you have a good memory. But for the most part, our issue in math is looking at patterns so that we can see the relationships between numbers. And our pattern here is that if we have y is equal to, now the important part of slope-intercept form is that y is by itself. And we have something called mx plus b. It means the number in front of the x is what we call the slope. And the number by itself is our y-intercept. How do these play out in the real world? The slope tells you how much you change. And this change is described as a rise over a run. How much are you going to rise versus how much you're going to run. While the y-intercept is just where we tag you on this y-axis here. So let's go ahead and give us an equation. Y is equal to negative 1 over 2x plus 2. Okay. So we want to label what my m is and what's my b. Because in slope-intercept form, as long as your y equals 2, for a line graph, you are automatically in slope-intercept form. So m is equal to negative 1 over 2, or we could say this is my rise is negative 1, and my run is 2, while my y-intercept is the number 2. So a way of looking at that, the y-intercept is when x is 0, y must be 2. Now, if we go ahead and plug in 0, 2 into the problem, if I plug in 0 here, what's 0 times anything? 0 times anything is 0. So y must be 2. And that's the cool thing about something set up in slope-intercept form, is if you do want to block off one of the variables, x, you always end up with a y-intercept. Now, let's go ahead and graph this graph at y equals to 2. So y is 2. Nope, that's our x value, right? So y is 2 going up. That's our 2. That's our free point. Graphing something in slope-intercept form is as easy as recognizing what your y value is. Sorry, the IXL score today is 90. If I didn't label that, sorry, I'll fix it in a little bit. And then our slope, our rise is negative 1. So it means we're going to go down by 1. I'm going to use a different color there. Our rise is negative run, and our run is positive 2. Here's our next point. We have 2 lines. So we have 2 points. We can draw a line. Ish. Let me use a ruler. Okay, if you have some type of straight edge, you can make your lines look so much nicer, like what I did. Now, a couple things here is we talked about the slope being the same throughout the whole run of the graph. That means the rise and the run will stay the same. So from this second point here, call this A and then call this B. From B, we can follow our slope. The rise was negative 1 and the run was 2. We can keep doing this over and over. Rise is negative run and run is 2. Hey, that's another point on the graph. Perfect. Now, here's also a trick about slopes. You guys see the negative sign? If I multiply the top and bottom by a negative, so if I put a negative on the top, I can move it to the bottom. That becomes a 1 over negative 2. And 1 over negative 2 is the same thing as negative 1 over 2. If you don't remember, if I have a negative in front of a fraction, negative 1 over 2 is the same as negative 1 over 2 or 1 over negative 2. As long as you only show me one negative. So I'm going to actually graph this slope here. I'm going to rise is 1, but my run is -2. So it means we're going to go backwards. So from my original point, my y-intercept is 2. I can go +1 up on the rise and go back 2, and that would still give me a point on the line. So you might say, Mr. Ko, where does negative go? You put it on top or on bottom, and it will still give you another point on the line, on the same line. I sometimes liken this line to a bus route, right? The bus is just going to drive on through, and the points along the way are just the stops. And it doesn't matter where you hop on the bus, you're going to be on the bus route. Okay, so this is what we talked about before. Slope-intercept form is one of our easiest ways to graph. Let's go ahead and do one more. Y is equal to -3/5 x plus, let's do +3. Okay, so my slope and my y-intercept. My slope is -3/5. My y-intercept is 3. So go ahead and spend a moment here to go ahead and graph this on a small graph on your paper. And then we can compare if it looks like mine. My y-intercept is 3. My slope is -3/5. -1, 2, 3, 1, 2, 3, 4, 5. We have 2 points. There you go. Now, today's skill is to work backwards, and it's really not that hard of a skill. I want you guys to write the slope-intercept form equation. Slope, intercept, equation of a graph. So we're going to look at the graph, and we're going to go backwards and write the equation from it. So graph 1, 2, 3, 4. And we're going to pick a slope. Here's 3, here's 4. The points given is 0, 4, and 3, 3. We're going to do this a couple of different ways. We're going to do it the easy, fast way, and then we're going to do our slope formula way. Okay, so that's what we need. Y is equal to mx plus b, where m is the slope, rise over run, and the b value is our y-intercept. Just to repeat that again. So easy one, the y-intercept, right? So the y-intercept is 4. B is equal to 4. Easy peasy. That's it. Easy peasy. And then my slope is rise over run. So to get from call this point A and point B, to go from A to B, do we go up or down? Ask yourself that. If I'm from A and I go to B, do I go up or down? I go down by how many steps? I go down by exactly 1 step. Thank you. So my rise is actually -1. So just write -1. Tell me the directions, right? And if I go down, how many more steps to the right now do I have to go to be? 1, 2, 3. 3 steps to the right. We're just counting. And if we look at the graph, did I really drop 1 and run 3? Did I rise and run? Did I rise by -1 and I ran by 1, 2, 3? I did. Now, this is nice because we can obviously see this on the graph. So y is equal to -1/3 x plus b. You guys ever play Legos? You just stick in the pieces? That's what we're doing. You guys ever used a vending machine before? Right? Stick in the quarters? That's what we're doing. You tell me what you see, and let's write out the equation to demonstrate that. Now, here's another way of finding slope. Remember we mentioned before, and we did this, the 2 points for slope. To find 2 points for slope, we had a nice easy equation, which was y2 minus y1 over x2 minus x1. Okay, we subtract the y's, that's our rise, and then we subtract our x's, that's our run. Okay, if you look at y, look at my hand, right? That's up and down, that's a y. Our run is x. So our rise over our run. Okay, our y, our rise, and our run, which is our x values. So we subtract them. So since I gave you the 2 points, we can call this x1, y1, x2, y2. And isn't 3 minus 4 -1? That's our y value. How about x? 3 minus 0 is +3. And that gives us our same slope. So whether you want to count it, maybe counting is a little confusing because maybe they use huge numbers. Then pick points. When we did this in IXL, hopefully you've done this on your homework. You haven't fallen too far behind. That we can just subtract the 2 points. So there's multiple ways of finding this. All right, let's do this again. Actually, let's pull up the IXL today and see what that looks like to show you that's not that hard. So here's an example from IXL, one of the easy ones, right? So they said, look at the graph. What is the equation of the line in slope-intercept form? Write the answer using integers, proper fractions, and improper fractions. Okay. Oops. So let's write our slope-intercept form. That's y equals to mx plus b. The more you write it, the more you know it. Okay. You can't say you can learn something without practice. So my m value, what is that going to be? What is my b value? Okay. Is your husband going to be rich and handsome? These are some characteristics. How rich? How handsome? So what's the b stand for? We said the b stands for the slope or y-intercept. This was the y-intercept. So looking at this graph here, where does the graph run into the y value? Where does the graph run into the y value? Hopefully you can see. It's actually going to be right here. So this is my y value. This is my y-axis. So it's simple as looking at the graph and saying, hey, where does this graph run into my y? And I probably should have zoomed in for you guys, but that is the number 8. Nope, that's the number 5, right? So B is 5. We're halfway there. Now, can someone pick another point where this line crosses through a nice cross? Like, give me an x value where this line crosses through a nice grid pattern. Because at 1, that does look nice. I don't want to guess that. Okay, someone told me 4. Bam, that is perfect. Okay, that's perfect. How can someone name another number? 8. Okay, let's look at 8. This is 8. right? That looks pretty, right? Those are easy points. Let's use those points because I don't know if that's a half at 1. I don't know. Maybe this is a half. Maybe this, I don't know. I don't be pulling the paper, staring at the monitor forever. Okay, so the cool thing is that we do have some points that are easy to tell. Now let's find the slope of that. How do I get from point A to point B? What's my rise? I had to go up 1 step, right? And I run 1, 2, 3, 4. Positive up, positive to the right. We say our slope is 1/4. Great, thank you. Let's do the one that says 8, when x is 8. Let's do point C. Let's go from A to C. From A to C, how many steps up now? We have to go 1, 2 steps up, okay? And we can run 1, 2, 3, 4, 5, 6, 7, 8. So let's try this. M could also be 2/8, but we can reduce 2/8, right? 2/8 can both be divided by 2, and we end up back with 1/4. So my point is that no matter what 2 points you choose for slope, they should always reduce down to the same slope. Whether I go 1/4 or 2/8, we'll still eventually get to all the points. 1, 1, 2, 3, 4. Bam, we're still there. We just had to take 2 stops rather than just one long express bus. So now that you have this, they asked us to reduce to the simplest form. So y is equal to mx plus b. M is 1/4, x plus b, which is 5. So if I wasn't talking, you could probably do this problem in like 30 seconds, as long as you're counting, right? So let's go ahead and check this out. If I plug it in, y equals, whoops, this shouldn't be capital. Y equals, I'm going to do a parentheses. I'm afraid it's going to mess me up. Parentheses 1/4 x plus 5. Let's see if this is a reflection of the graph. My y-intercept is 5. Yep, right there, that's 5. And then I rise by 1 and I run by 1, 2, 3, 4. Yep, that's my graph. Let's see if it works. Cross your fingers, right? Awesome. This problem looks totally crazy. But that's again right out our form. Y is equal to mx plus b. If you could tell me the slope and the y-intercept, we have this equation down. So m equals 2 and b equals 2. And again, I think the b, the y-intercept, is easiest to look at. So what do you think the y-intercept is for this problem? I'm going to zoom in for you guys. Maybe you guys can take a guess. What does that look like? I'm hearing negative 100. I would agree with you. That looks like negative 100. So my b is negative 100. Easy peasy. We're halfway there. Sorry. Now, let's take a look. If I'm walking along this line, this looks like a nice point, right? If I want to keep going, walking along the line, this looks like a nice point. So we have a nice point when x is 10 and x is 20. So we want to be careful here because we're not counting by ones, we're counting by tens. So what's the rise from negative 100 to 20? See how that's 20? So you can count 10, 20, 30, 40, 50, 60, 70, 80. You could do that. And then our run is 10. So we're going to write positive 80 over 10. If you're not sure about that, we can write out the points. This is 10, comma, negative 20. And down here is 0, comma, negative 100. And if we write the slope formula, y2 minus y1 over x2 minus x1, we could do this too. Negative 20 minus negative 100 over 10 minus 0. This becomes a positive 100. 100 minus 20 is 80 over 10. Same thing as if we just counted or we did the formula. Okay? So you want to learn how to do both of them because sometimes it's easier to do one or another. What if they didn't give me a graph? All right, so we can reduce that to 80 divided by 10 is just 8, and that's fine. Just an FYI, if you ever see a number just like 8, remember there's an invisible 1 underneath it. Okay, there's always an invisible 1 underneath it. An invisible 1 underneath it. Okay, let's assemble our little pizza pie here. Y is equal to 8x minus 100, right? Because our b is a negative. Right? Probably some of you guys are working on IXL right now. And you're like, man, this is pretty easy. Let's see, we have 3 people have started already. And you guys, oh, we have 1 person who has started. And they're already at 70. Okay. All right. So writing the equation based on a graph is fairly easy as long as you know what to look for. And that's what algebra is trying to teach you, right? You have to know what you're looking for and which tools to use. And if you have the right tools and you know what you're looking for, of course, this is an easy problem. And if you don't and you're confused, it's going to be very difficult. So that's right. Y equals 8x minus 100. Okay. Excellent. Thank you. Thought so. Now, looking at this problem here, the y-intercept is going to be -2, -4. It's between that, right? So it's -3. And if I want to count the rise of this problem, come on. The rise from -3 to my easy point, that's an easy point, that's an easy point, that's an easy point. Any of those are easy points. Is the rise is 1, 2, run is 1. Let me do that again. The rise from here to here is 1, 2 over 1. 2 over 1, easy peasy. So we actually have everything we need. If you remember what I said, the y-intercept is -3 and the slope is 2 over 1, or just 2. So y equals 2 over 1, or just 2x minus 3. I think I spent like 10 seconds on that problem, right? You can probably check the YouTube video. Submit. There you go. Okay. All right, let's work on the next section today. The next section is actually going back to solving for not x this time, but we're going to solve for y. So we talked about 2 forms. We talked about our standard form. Standard form. Oh, yeah, standard form. And slope-intercept. Okay. Let me write them out real quick. Standard form is ax plus by equals to c. Slope-intercept form is y equals to mx plus b. The main thing about standard form, almost always a and b are whole numbers. They're not fractions. They're nice whole numbers. And x and y are both on the same side. On slope-intercept form, y is alone, and automatically gives us, if you can solve for y is alone, we have our slope and our y-intercept automatically. So we're going to today convert from standard form to slope-intercept form. And it really is like a 5-minute lesson, if that. If I say 3x plus 2y equals to 4. Okay, 3x plus 2y equals to 4. This is in standard form. But how can we change this into slope-intercept? What letter is alone here? Y. So solve for y. And that's our whole goal here, is to solve for y. We normally solve for x, right? When we're solving for our variable, but we're solving for y here. So let me ask you, what do we get rid of first? The 3x or the 2? Which do we get rid of first to solve for y, to get y alone? So if you're not sure, if you remember the story of you wanting to be alone in your room and your parents and all your family members all of a sudden crowd your room, probably happens every night to some of you guys, you have to find strategies to get rid of them one by one. So we said, we get rid of the person that's farthest away from you, 3x, farthest away. Then we'll get rid of 2, closest. Get rid of the person that's closest to the door, kick them out. So what's the opposite of, okay, so how do I get rid of this 3x here? That's a positive 3x. We're going to minus 3x to both sides. So we're going to minus 3x to both sides. Minus 3x. Can I combine 3x and 4? Nope, they are not like terms, so we leave them alone. Negative 3x plus 4. Okay, the note is these are not like terms. Leave it alone. Now, I don't have to get rid of one more number here. The number is 2. How do I get rid of a times 2? We divide by 2. Now, please look at how I'm going to divide. I'm going to divide everybody by 2. Everybody by 2. If it's fair to one side, it's fair to both sides. If you get pizza, I get pizza. If you get an increase in your allowance, I get an increase in my allowance. Y is equal to negative 3 over 2x plus 2. And we're done. All these problems, when it comes to standard form to slope-intercept, it's pretty much 2 steps. That's it. Just 2 steps. But you have to practice these 2 steps so you can be very fast at it. Okay, let's do another example. 4x minus 5y equals to 20. Now, we could graph this graph, right? Plug in 0, look for the intercepts. So on a side note, we could graph it and say, hey, my x-intercept here, cover up the y. What's the x-intercept? X is going to be 5. If y is 0, 4 times 5 is 20. So our x-intercept is 5, 0. Let's look at our y-intercept. If I cover up my x, I'm solving for y-intercept. We did this in IXL. Negative 5 times what is 20? Negative 4. So 0, negative 4. These are my intercepts. If I want to graph it on the side, we have 1, 2, 3, 4, 5. Put a dot. Negative 1, 2, 3, 4. Put a dot. And this is our graph. Not hard to graph, and you guys did this. Or I hope you did, right? It's been over a week. Now, what if I want to change this to slope-intercept form to graph instead? And I think slope-intercept form is faster to graph, even though this wasn't that much work. So let's solve for y. Solve for slope-intercept. And that's y equals to mx plus b. If you want to know how creative math people are, why do we call this slope-intercept form? Because there's a slope and an intercept. You ever have a family member that always asks like obvious questions? Can you tell me what flavor this chocolate ice cream is? Can you tell me what fruit is inside this strawberry cake? Can you tell me what color is a yellow submarine? You have any family members like that? You're like, come on. So we call this slope-intercept form because the slope and intercept are described in that equation. Okay, so we're going to get this here to this. And the goal is to solve for y. So we rewrite that again. You don't have to. I'm just writing it so you guys can see it. So we're going to get rid of the what first? The 4x of the 5, just like our last move. So we get rid of what's farthest away, what's closest. If you got to donate stuff to the Salvation Army to clean up your house, to get rid of the stuff that you're really close to or that you don't even care about, they're far away. So let's do opposite operations on the 4x because it's farther away to both sides. Please don't do this. I've seen kids do this where they minus everyone. But remember, we have an equal sign here. And does it look fair that I subtracted negative 4? If I subtracted 4x from the left side twice, that's not fair. That's like double taxation. Negative 5y. Don't forget the negative, please. Oftentimes people forget the negative because you're rushing. You're Russian. And then our next move is, how do I get rid of this negative 5? Is negative 5 subtracting or multiplying that y? And a reminder, if numbers are next to each other, that's always a multiply. So the opposite of multiply is a divide by negative 5. And I'm going to write divide by negative 5 to everybody here, please. Everybody. You can write this as one big fraction, but I like writing it as separate fractions. Y is equal to negative is a positive 4 over 5. And 20 divided by negative 5 is a negative 4. Sure. Did you want the example on the graphing or us solving? Solving, right? Oh, graphing. Okay, sure. Okay, so y is equal to negative 4 over 5x minus 4. And that's it. We're done. Now, I want to make sure that I can graph this. My y-intercept is negative 1, 2, 3, 4. Put a dot. And my rise over run, my rise is up 1, 2, 3, 4. My run is 5. 1, 2, 3, 4, 5. I want you to look at this graph versus our graph that we had up before. Look at your notes. Does our graph look like our graph from before? It's exactly the same thing. Exactly the same thing. Okay, so in IXL, you will be practicing this till a smart score of 90. So make sure you can practice it and do this soon. I'll be checking this homework, of course, when you guys return to me on Tuesday. But all the old homework, if you guys don't get it done by probably tomorrow, I'll probably send out another mass notification to your parents that you need to catch up on homework over the weekend, okay? So make sure you get it done. It's only going to cost you like 10 minutes of your life. Okay? Thank you. If you guys are done, you guys can leave. I'm going to go ahead and stick around and answer questions.